Hello, friends, comrades, fellow creatures of life. This is a new lecture playlist under science lectures. It's going to go over the nature of science. It's going to go over the importance of science. In particular, this lecture is titled The Importance of Science. But it's really a brief history on some important figures of science, of which I've covered some scientists in my philosophy section on pertinent peoples of past and present, which is a spin-off of Plutarch's Lives of the Noble Greeks and Lives of the Noble Romans. This, however, is going to be a more in-depth study in science, and so I place it outside of philosophy, but we really need to understand that before the time of Sir Isaac Newton, science really was not a formal discipline. It was really kind of slouched inside of philosophy. So I hope you enjoy the lecture. I hope you enjoy the series, and stay tuned for more. I begin with the importance of science. Lecture 1. Sir Arthur Eddington wrote an essay titled My Two Tables, and I highly encourage it. It's a wonderful read. Science is the most powerful tool that humanity has developed to understand and control their world. Philosophy is one of the best tools that humans have for penetrating confusion and obscurity. It helps to build a bridge between incomprehension and chaos. Science, like philosophy and every other complex study, needs to be analyzed and scrutinized carefully in order to be understood. Science used to be a branch of philosophy, as I have said, in Sir Isaac Newton's time. Scientists during his time were not called scientists as to their occupation, but were in fact regarded as natural philosophers, where you see a lot of the scientists and the scientific works being done during the scientific revolution. A lot of these scientists are referring to their work as being in the department of natural philosophy. And they were called natural philosophers, not scientists. So, science just so happened to become a philosophy that worked. It became an autonomous discipline only in the 18th century, occurring alongside the Enlightenment in Europe. But some questions today overlap, or at least they seem to, both philosophy and science. And so we have the history of science and the philosophy of science, and the history and philosophy of science. However, we have questions like, what is space? How should quantum mechanics be interpreted? Etc. These are some questions pertinent in science. Scientifically informed philosophers and philosophically inclined scientists should have conversation with each other. I hope that this is an encouragement for both to work with one another. Major questions would be, what is the difference between science and pseudoscience? When is a scientific generalization justified? I.e., how do we distinguish between coincidence and natural laws? Or, as many propose, all science is reducible to physics, i.e., psychology can be deduced from biology, biology deduced from chemistry, and chemistry deduced from the physical laws of our world and our universe. However, arguments have to be made for each and every claim or view, and no worldview wins or is supreme by default. Does science describe reality? An important question. Or, is science a useful tool in order to describe what we think is real based upon our experiences through observation and method? After all, we can only describe the world that we see. We do not see the entire fundamental world that we can describe. Are quarks and electrons, etc., real? Or are they only hypothetical entities? Are scientists and science objective, or do both have inherent perspective, bias, and subjectivity? A very brief history of science from the world of classical antiquity. to that of 1900, the dawning of the 19th century. And for the most majority of human history, the questions about the nature of the world were answered by religious authorities. Mathematics was born in Egypt, and the Babylonians were the first to apply mathematics to astronomy. I've studied a little bit of the classical physics from ancient times until the late 19th century. This will be a history up from the classical period of antiquity to 1900. The pre-Socratic philosophers in ancient Greece were in fact the first known group to develop a systematic science, starting with Thales of Miletus. You will see him in my history lectures as well as in my philosophy lectures. He existed in the 7th century BCE and was the first to posit a non-supernatural explanation for earthquakes and lightning. He was able to predict solar eclipses and droughts. Empedocles discovered air pressure and, in a sense, also the invisible in nature. Democritus, again, theorized that matter was made up of atoms, or uncuttable things that could not be divided. The smallest thing that could not be divided. And of course, now we know that atoms can be split into smaller particles. Aristarchus proposed a heliocentric view of the universe. In our modern day, we know that atoms are in fact cuttable, and so really the term needs to be changed, but we don't change it, i.e. nuclear power and weapons as a result of the splitting of the atom. Eratosthenes and the splitting of neutrons. But Eratosthenes was the first to measure the size of the Earth by using two sticks, distances and shadows. It was basic trigonometry. Pythagoras started a school dedicated to math and its application to nature. He did not think himself wise, but he loved wisdom. Much like Socrates, he was also the first man to define philosopher as the lover of wisdom. Pythagoras had also invented music theory. Heraclitus and Parmenides were also crucial in the development of Plato's philosophy, and their debates were on the foundations of what justifies knowledge, reason, or experience. And is nature fundamentally permanent or changing? Is it permanence or is it mutability? Heraclitus again says that nature loves to hide, and that's why we need to find it. Chemistry at this stage in human history consisted of 5 elements of earth, air, fire, water, and what they termed everything else was ether. Hippocrates and Galen developed the first scientific approach to anatomy and medicine. And we see that his approach introduces experiments and records as opposed to shamanistic magic. Science increasingly developed during the Roman Empire from 27 AD to 746 AD. We have science in Christendom from about 400 AD to about 1400 AD. Science in Christianity in Europe, or the Middle Ages, the early Middle and late Medieval Ages. The Christian world, in that world, there were European scientists during this period, but they were generally isolated and extremely marginalized. For example, eyeglasses were invented during the Middle Ages, the using of glass and stained glass windows in order that monks could read more, and scribes could also write more. Also figuring out a new dating system was extremely important. We have from the Immaculate Bead, a lot of copying, documenting, and record keeping was done in the Middle Ages, but much of scientific advancement was halted with the exception of what was done in the Islamic world from around 500 to 1300 BCE. The Islamic world saw advancements in medicine, astronomy, and chemistry. The rise of scholasticism in the 12th century, the 1100s in Europe, tried to incorporate Christianity with ancient Greek or Aristotelian views, and this was rejected by the Pope in 1237 CE. The rejection of necessarianism led to the development of modern science and the Renaissance. The idea that God didn't have to create things in a certain way. During this time, we see people like St. Thomas Aquinas, who endorsed what he called natural theology, knowing God by studying the underlying nature of the created order. In the 13th century, and this was huge. It started a revolution, and thankfully people started to think again in the 14th and 15th centuries. Aquinas, however, recommended fusing both science and religion together as a philosopher. Free discussion was then demanded, weakening church sovereignty and then therefore giving rise to the Italian humanists of the Renaissance, which we'll see in my history lecture on the Saga Humanitas, Renaissance, and Reformatio. However, one of the most important men of all time, Sir Francis Bacon, which I also have a lecture on as well, was extremely important because until Bacon, most people in academia referred to mostly Aristotle and Aquinas. Francis Bacon introduced what was called the scientific method. Being a genius is like being able to run fast, he said. You may be able to also to travel afar, but unless you have a map, you will be lost. For Bacon, genius was not necessarily needed. He suggested that people need to make extremely careful observations and measurements, and that's all that was required. Firstly, he said that empirical observation and experimentation was important, and he also said that rational analysis, mathematical modeling, and deductive reasoning was extremely important as well. For Francis Bacon, science is slow and meticulous. It comes by observation and experiment, not by employing genius. Within a few decades of Sir Francis Bacon, new theories and technologies emerged. It should be mentioned here that the 16th century printing and publishing, as well as the increasement in communication between cities and civilizations as a result of the 15th century Atlantic voyages and discovery of the New World, helped to spread ideas and innovations as well. Sir Robert Boyle's theory of gases, which I have a lecture on Boyle as well, laws of electricity, and then William Harvey found out what blood is for. And he found out the blood circulation properties and its functions. New technologies during this time were the telescope, the microscope, the thermometer, the printing press, the gunpowder in China, and then also the compass. Emphasis on wide cartography or map making and the navigation advances were important as well. And this all leads up to the advancements made in astronomy during the scientific revolution. Ptolemy and Copernicus. I have not written on Ptolemy, but I have written on Copernicus. You can see him in my historical lectures. Was an extreme, huge importance. Ptolemy had a geocentric view of the universe. Newton had a heliocentric view of the universe. 1400 years, however, of geocentric view was finally eclipsed by Newton. Ptolemy's astronomy was super and superbly accurate and amazingly useful, but it was not true. The evidential data in regard to the heliocentric view challenged and shocked the West at the time and demanded man to rethink his place in the universe. This was a mind-blowing idea to many people during the Renaissance period who were mostly religious. And the Copernican system and the retrograde motion of the planets was as well. You see Tycho Brahe and Johannes Kepler. I didn't talk about Brahe or Kepler, and this is why I'm talking about them now. But they answered Copernicus's problems. His math was not wrong, only his assumption that the orbit of Earth was circular. The answer that Brahe and Kepler proposed was that it was not circular, but that it was an ellipse. And then we have Andreas Osiander. Most people don't know about him, but he proposed an idea of what today is known as instrumentalism, which is that science does not really describe true and complete reality, is rather a tool that can be implemented and used in order to get around in the world. And then we enter the life of Giordano Bruno from Italy, who proposed that life exists on other planets. And for his time, this was an extremely crazy idea. The church did not like his speculations. Therefore, he was a heretic. He was burned. Leonardo Bruno was, or Giordano Bruno was burned at the stake. And then until Galileo 100 years later, we emphasize the importance of Galileo's telescope. His last words was, "It moves regardless." As this was alleged after his last, his recantment. He was made and forced to recant his beliefs, and as he was storming out, it is a legend that when he stormed out, he said, "It moves regardless," and so what he was talking about was that the Earth was moving, that the Earth was not the center of the universe. He was saying that the sun was the center of the universe, and that the Earth moves around the sun. This was quite a revolutionary thought. After all the many millions of years that humans, and even then they didn't know about millions of years, but after all the years that humans now in historical retrospect, after all the years that people have been looking at the sun and thinking about it, now we finally know that the sun is not the center, or that the Earth is not the center of the universe. The Earth does not go around the Earth, but the Earth goes around the sun. And so we see that the most important person in the entire history of science is Sir Isaac Newton, who I've written a lecture on. He was born in 1643 and died in 1727. Natural scientists of the Enlightenment age turned away from the Aristotelian model of the purpose, or the telos of motion, to the laws and mechanisms in nature. And this is epitomized in what he wrote called Mathematical Principles of Natural Philosophy. Almost all modern technological innovations of modernity trace their origins back to the Principia Mathematica by Sir Isaac Newton. Newton unified disparate fields of science, celestial mechanics and terrestrial mechanics, and he fused them together. He thought that the whole universe was one big machine, a deterministic system of causes and the necessary effects, which he described as a mechanism. Newton also practiced alchemy, sadly enough, but transforming one substance into another, which pioneered the study of the elements and that eventually morphed into chemistry. See Joseph Priestley's phlogiston, his theory, which is magnesium gains mass when it's burned. Antoine Lavoisier realized that Priestley's dephlogisticated air was oxygen. So what Priestley describes as dephlogisticated air was what he said was oxygen. And this was in the year 1774, to put this in historical context. And so we know that materials are deoxygenated and become oxygenated when they burn. Carl Linnaeus was the first to start biological taxonomy. Charles Lyell was the first geologist. Charles Darwin came up with the first mechanism of natural selection, proving microevolution. And then we have Mendel's genetics as well occurring around this time. Well, one might ask, how does science work? Well, one key element is empiricism, for science is a focused organization and a systematic version of how we all know the world by experience. In fact, we are indeed at the most basic level experiences, but there is more to science than that. All knowledge comes from sense experience. As an empiricist, I am influenced myself by John Locke and Berkeley and Hume. Those are the British empiricists. And as an empiricist, I do see many problems with a straightforward empiricist view of science. Um, but anyways, from past examples, we see that sometimes to prove a theory satisfactory, we must go beyond the actual empirical evidence. And as we'll see, a simple empiricist picture alone is too facile because it ignores the true complexities of an issue. For example, brain states do not cause self-conscious events. And we may be able to prove that brain states do cause self-conscious events, and I think they do. But we think of a modern physicist, Sir Roger Penrose, seems to suggest that we need a new physics to explain consciousness, and that biology and the complexities of the psyche may be influenced by the quantum world, the world of quantum mechanics, which we may have to go beyond physics or metaphysics in order to explain applied physics of the chemistry and biology. But anyways, I digress. Galileo once said that nature is written in the language of mathematics, or the language of numbers. Science translates this mathematical language of numbers successfully by use of mathematical models. Empiricism plus mathematical models equals is the greatest science that we could possibly conceive of. For much of the history and philosophy of science, though, reason and experience were seen as competitors as to which one would claim to be the true foundation of knowledge. However, reason champions and experience champions. Those who were on the side of reason were Parmenides, Plato, Galileo, and Descartes. The people on the side of experience were Heraclitus, Aristotle, and Francis Bacon. These figures are only a few philosophers in the debate of epistemology, or the theory of knowledge. Many now believe, after much theorizing and writing, that there is a combination between the two of reason and experience. That there is the question then arises: how should they then be combined, or rather, what is this combination exactly? Although there is not a sharp divide now between rationalists and empiricists, we must recognize that the combinatory approach must be addressed. Most, if not all, professions in science now require profundity over mathematics in order to do science. That's why I'm not a scientist, because I was really awful in mathematics, and it didn't suit my disposition as a humanities major. And so when we look at the history of philosophy and the history of science, we see that both philosophy and science are really the history of philosophy and the history of science. The breakthroughs in philosophy and science and their related fields have mostly occurred via interaction with the work of previous philosophers and previous natural philosophers and or scientists. Now, if I have seen far, Newton said, it is because I have stood on the shoulders of giants, end quote. This sort of statement can imply that science has a unique social structure with the work of others. There's peer review in every discipline now at the research level for teachers in their respective departments. We have societies, historical societies, philosophical societies, scientific societies, theological societies, and psychological societies. And we use these societies for research in order to develop hypotheses, which is the bedrock of scientific inquiry. And it's the hypotheses and hypothesis are you can't get any are the bedrock of creating theories, which you can't get more sound than a theory, a scientific theory. However, things can be complicated when using these tripartite elements of empirical evidence, mathematical modeling, and social peer review. So what happens when the inferences or results from an experiment appear to contradict the socially acceptable dominant paradigm? Okay, and this is where we get to paradigm shifts. We get to Thomas Kuhn. We're going to go over Kuhn and Lakatos, and we're going to go over a lot of these other writers that wrote on paradigms and systems and theory and programs and whatnot. But a paradigm is simply a worldview underlying the theories and methodology of a particular subject. But it's not very clear, however, what shall we do when the mathematics does not match with empirical experiences? And we see this in quantum mechanics. So this creates scientific and philosophical problems which are not easy or simple to figure out. Obviously, as a historian, I don't understand quantum mechanics, and so really I'm kind of at the whim of physicists at this juncture. However, a history of the philosophy of science in the 20th century, we will go over logical positivism and logical empiricism. Now, before I go over logical positivism and logical empiricism, I do want to end this lecture because I want to go over logical empiricism first and the next lecture, and then go into logical positivism, because I think logical empiricism was a precursor to logical positivism, and or no, my apologies. Logical positivism came first, and then logical empiricism. So I want to give you a very strong background in logical positivism before we jump into logical empiricism, as a result of the limitations of logical positivism. So the next lecture will be titled Logical Positivism, and we will go over what that is, and then we will basically merge into logical empiricism. I hope that you have learned something in this video. I hope it has been informative. I hope that it will help other people understand the importance of science, which is what this lecture is about, and that the fact that science was relatively slow up until the time of Sir Isaac Newton, but the foundations were found in places like Egypt and Mesopotamia, and those were the places where science was born. Wasn't systematized until in the time of the Greeks, from the 8th to the 6th centuries BCE, and that is really where we found the birthplace of not only philosophy but also history and science. Thank you for watching, and see you in the next video.